Good morning to all. Good morning here in Cairo and on internet. Welcome to this session on the theme of harnessing science, technology and innovation for advancing the water energy food nexus. My name is Jean-Marc Forez. I am Regional Program Leader in FAO's Regional Office for the Near East and North Africa. And I'm pleased to moderate this session today. The session is organized in association between the FAO Science and Innovation Forum, which is organized this week in Rome at the FAO headquarters and in hybrid format, and the Cairo Water Week. We are particularly proud to bring together these two major events. The FAO Science and Innovation Forum is organized during the week of the World Food Day, which was 16th of October. It focuses on highlighting the centrality of science, technology, and innovation for agri-food system transformation. The Cairo Water Week is the 5th edition of an event organized by the Egyptian Ministry of Water Resource and Irrigation, and which is increasingly recognized as a regional and global landmark, a platform for exchange of knowledge and experience on addressing pressing regional and global water issues. Today we will dig deep into the water, food, energy nexus. We want to understand the linkages between water, energy and food, learn about the situation in the region, and understand what exactly means adopting a nexus approach. A keynote presentation will introduce the subject, followed by a panel discussion. To introduce the session, I'm glad to give the floor to Dr. Abdulhakim El-Wire, Assistant Director General and Regional Representative of FAO for the Near East and North Africa, who will be followed by our guest speaker, the Minister of Water and Irrigation of Egypt. Hakim, you have the floor.
Assalamu alaikum jami'an, sabah al-khair. Good morning everyone. We are anticipating His Excellency Minister Hani Swelem, Minister of Water Resources and Irrigation, to join us any minute. Excellencies, distinguished panelists and colleagues, ladies and gentlemen, let me first wish you all a very good morning today and a successful day. As we are starting this session at the 5th edition of the Cairo Water Week here from Cairo, we're also a dual multitasking, also addressing the Science and Innovation Forum of the Food and Agriculture Organization, which is ongoing as of today in Rome at the headquarters of the FAO. And this event serves and addresses participants of both events in Cairo and Rome, and all colleagues who are connected with us. It gives me a great pleasure today to welcome you all to this very special event for the Near East and North Africa region, connecting Rome and Cairo at the same time. The event is jointly, of course, organized, as I mentioned, between these two ongoing events. The Near East and North Africa region is probably the most represented region where the challenges facing water scarcity and water security, food security and energy security must be addressed in an integrated vision, optimizing the sustainable use of natural resources along the path towards achieving the 2030 agenda. In this region, particularly, fresh water and fertile lands are much more scarce than anywhere else in the world. And access to energy is a growing challenge for many countries in the region, adding to the prominent crisis and shocks it already faces under climate change and protracted conflicts. The nearest countries of the region suffers from political instability, economic crisis, displacements and migration, and leading to food insecurity. We also lately the devastating floods sweeping United Arab Emirates, South Sudan, Iran earlier this summer. Bahrain, Kuwait, Oman, Qatar, and Saudi Arabia also witnessed heavy rainfalls this year, something the arid region has not seen during the summer in over 30 years. We also saw hard-hit drought waves across Europe, all of which is a reminder of more to come in the coming years if adequate collective actions are not taken. When combined with the Russia-Ukraine war, the disruption on global energy and food supply chain, and the resulting inflation, the options for this region are becoming narrower, with clear direction towards enhancing inter-regional cooperation and intersectoral policy coherence and integration. Here I am referring specifically to the water, energy, and food agriculture sectors. Science, technology, and innovation are critical accelerators to achieve the SDGs. Yet it is imperative to acknowledge the need for securing the right enabling and conducive environment at all levels, institutionally, technically, legally, and in adequate investments to harness the benefits of technological and science innovation solutions. As you can see, the session agenda this morning, we are glad to host a number of distinguished experts on the water, energy, food nexus to highlight on the need of making use of innovative scientific and research results to face water scarcity on the ground. The opportunities offered by technology and innovative approaches in order to help countries to overcome the complex challenges for achieving food security within sustainable use of natural resources. We very much believe without the improper use and exploitation of scientific and research and innovative solutions, we won't be able to overcome these challenges that we've referred to, from climate change to water scarcity to the protracted conflicts and the ongoing food insecurity. We are glad to welcome later His Excellency Dr. Hani Suwailem, the Minister for Water Resources and Irrigation of Egypt, who is himself a leading water scientist. He was recently awarded the 2022 Water, Energy, Food Ecosystem Nexus Prize by the Partnership for Research and Innovation in the Mediterranean Area. And we're expecting him to join us any minute during the session. I would ask my colleague John Mark, the moderator, when the minister comes to give me the chance to introduce him so that he can address the participants. With that, I think, John Mark, you may proceed with the program of the session. Thank you.
Thank you very much. And as we do not have much flexibility in terms of the duration of this session, we will move on directly to the keynote presentation, and indeed when the minister will join us, we'll be glad to hear his words. So for the keynote presentation, we have the chance and the honor to have Dr. Rabi Mohtar, who is professor of the Department of Biological and Agricultural Engineer and the Zachary Department of Civil and Environmental Engineer of Texas A&M University. He has a lot of hats, and if I had to list them, we would take the whole session. But let me just say that he founded the Texas A&M Water, Energy, Food Nexus Initiative, and many of us know him as the Dean of the Faculty of Agriculture and Food Science of the American University of Beirut. So it's difficult to find better than him to introduce the subject of water, food, energy. And if technology allows, I'll now give the floor to Dr. Rabi Mokhtar for his presentation. Are you with us?
Yes, good morning to all of the attendees physically and those who are joining us in person, and those who are joining online. Thank you so much, Jean-Marc, for the kind introduction, and thank you for the organizers for giving me the chance to share with you some of the thoughts on the water, energy, food, and circular economy. You can hear me well, and the slides are showing okay?
We hear you well, and we see the slide. Yes, please go ahead.
Okay. I will be discussing defining the nexus. There's a lot of definitions out there for the nexus. At least I'll share with you some of one of those definitions that we've been working with to level the field in the upcoming discussion for the session. Share with you some success stories and application for the nexus and some of the future opportunities and some concluding remarks. I'd like to welcome a partial list of those who have been working in our lab for the last 10-15 years. There's additional members who this slide cannot fit. We've been working on the analytics and the platform for the water, energy, food nexus for a number of years. In particular, the dimension of the water food is of special concern in our group, looking at the green water space and also looking at the feasibility of non-traditional water. We all believe that agriculture is one of the main users of our water, freshwater resources, and we need to look at alternative sources. We also teach a course, a graduate course on the water and energy food nexus, both in a online, regular, as well as an executive education format. By way of introduction, the water, energy, food is not here to replace any of the disciplines. It exists only as a foundation to build on the existing water, energy, food disciplines, builds on the knowledge we have in water productivity, energy efficiency, and integrated water resources management. I'd like to highlight three elements of that nexus that is actually crucial: the interlinkages between the water, energy, food, and the ability for us to really reduce that tight interlinkages for a bit more refined sustainability and resilience in the future. We'll discuss this in a minute. It's also identifying hotspots for intervention, but the most important element of the nexus that I'd like to highlight is the trade-off. We are entering a state where we don't have abundance on any of our primary resources, so there are some trade-offs that I'll talk about throughout. But the nexus is the way the continuum. The other element of the continuum is what does the nexus means in terms of inducing change. And as we all know, especially in the region, we are in a region where water is a source of conflict. So how can the nexus facilitate discussions both in the supply chain and political economy towards a more dialogue and cooperative zone? And I think some of the examples are touch on this aspect. So the nexus is not only the analytics and the definitions and the quantification of the interlinkages and the definition of hotspots and trade-off. It is also a catalyst for change and for inducing some of the changes that I'll talk about. So what are the 8 questions to set up the nexus as a platform? I'll start with a critical question. So the critical question is the hotspot that I defined earlier, which is the basic problem or issue that needs to have a solution. The second would be at what scale we're looking at this hotspot, both in terms of physical scale but also temporal scale. Next next is the system definition, and this is important because we may choose, depending on the specific problem we have, depending on the specific scale, to ignore some of the important processes. So we don't need to include everything in that system definition, and depending on what problem we're setting up and where are we may ignore some of those, because you cannot account for all of the processes involved in the nexus. So that step is important. Next is to identify the stakeholders. Now, we all realize that for a nexus to really, I heard the main presenter earlier talk about involving the stakeholder, involving the broad spectrum. So it is important that we define, identify those stakeholders that are impacted and being impacted by these solutions. Next is what type of data is available and what type of data I need to fetch to allow me to answer some of these questions related to the interlinkages between these resources. Next is the assessment mechanism. Sometimes we ignore to really define clearly what the assessment mechanism. So I'm putting this early on before I start the actual potential solutions, because we need to be bias-free in looking at what criteria I will use for defining possible solutions for the critical questions I pose. So the assessment mechanism would involve the stakeholders, would involve surveys, would involve looking at those who are going to be implementing some of these solutions and asking them not only the scientific questions with the science community will seek, but also the preferences, what type of preferences they have. And I'll give some examples of this later on. Now, once we develop the assessment and look at the data, we start looking at possible solutions for the critical question in mind. And that involves a lot of analytics, that involves a lot of trade-off, that involves winners and losers. And this is important to realize that there will be winners and there will be losers in this, but the analytics will allow us to define possible solutions at the community scale that we are better off at the community than looking at a silo approach to these critical issues. Last but not least is the communication mechanisms. How do I translate those solutions into implementable, into solutions that can be communicated clearly and transparently with the stakeholders? So that communication is, I would say, the last step, but that's an important step that allows for the scenarios and for the possible solutions, and those have been identified by the community of stakeholders as more favorable to be communicated to the for implementation. And again, the loop goes again and over, depending on whether we have achieved our target or not. So I thought this would be a good starting point to define how we get by identifying some of the possible solutions for the critical questions we are facing in societies today. We have taken the nexus globally. In fact, this is a partial list of different applications. We started with the food security question in Qatar that guide the state of Qatar in terms of what does it take to increase the domestic food production. We've taken it to Lebanon more recently and looking into the nutritional aspect of the diet. We all know that Lebanon is facing a unprecedented economic crisis, and the exported food or the imported food is not attainable in terms of cost. In fact, yesterday I was reviewing that some of the basic commodities in Lebanon, such as lentils, will be subject to foreign tax. So it's very critical that we look at these nexus approaches to look at to what extent can Lebanon produce its own basic food diet that is at the core of it would be a nutritious food. We've taken the nexus to bridging the Texas water gap. Texas has a 40% projected gap in the next 15 years. So what are some of the solutions? I'll talk about this in a minute, but some of these solutions go beyond the water sector. This is why a nexus approach is actually preferable, because some of the water solutions that we identified in Texas has to be implemented by the energy sector and by the agriculture sector. So defining a stakeholder base that broader than the hotspot that we're defining is very critical. We also look at the hydraulic fracturing water transportation trade-off. I'll talk also about this as an example later. We did have several case studies with renewable energy deployment, and some of the implication of renewable energy on agriculture because of land need, but also on water, because some of the renewable energy could be high consuming water. So we need to look at the introduction of new technology without having to compromise other resources. We've looked into application in the Mekong River Basin. We looked into the Gediz Basin in Turkey, where agriculture is the predominant economic engine for the state. More recently, we were in Morocco and looked at the trade-off between phosphate production in terms of water use and the trade-off between water allocation to phosphate industry and agriculture and tourism. And this is also an important study. In Morocco also, we looked at the Sustainable Development Goals implementation, and there will be additional discussion on that later in the slides. We did the trade-off in hydropower and food security in Nigeria. And I will also talk about some of the application in Texas with the San Antonio case study that we've been working on for the last 9 years. So how do we get by in defining and quantifying these scenarios? So this is a slide that shows our approach to this, and this is early on in the development of the Nexus tool. Now we are now in the 2.0 version, but the basic structure did not change, so I'd like to explain that with the original Nexus tool. So there is an admin interface that looks into all of the interlinkages data that the user does not need to see. And those would be looking at all the portfolio of the food, the water, the energy, and the requirement, the footprint, and the interlinkages between water, energy, food, and land, imported data when it comes to water import, when it comes to the food basket, supply chain, and trade. All of those interlinkages are embedded in a database that can be accessible based on a user interface that allow the user to build a scenario. So there's a lot of data and data set that will have to be built by the administrative group that does not need to be transparent to the user. So the user will come in and start asking questions and build a scenario, whether it's a food self-sufficiency, whether it's a water source and looking at different water sources or different energy sources, or even looking at sources of import countries. And here I'd like to stop for a second, because sometimes economics certainly is a big criteria for building those scenarios. However, there may be other important aspects beyond or beside the economics that are important. In terms of resources, for example, even though there might be a certain country that is cheaper to import food from, however, because of the geopolitics, it may not be feasible to do that. So there are other factors that will dictate some of these scenarios and solutions. Now, once we build that interface and once we quantify what I call the complete footprint for water, for land, for carbon, for the financial, for energy, once we identify the scenario and develop a complete footprint for these scenarios, those are science-based data set that the tool will actually provide. That's half of the input that is required for what I call the sustainability index. The other input, which is as important, is the policy input. And this is where you engage the policymakers with a survey asking them about their importance and preferences. And they may choose national security as an example instead of looking at only the output in terms of the footprint. And this is very important. So the sustainability index that allows us to choose some of these solutions will be a function, or is a function, between policy input and the science input. And that is a very important aspect that we can discuss in a minute. So let me walk you through some of the examples, starting with Qatar. In Qatar, the question was very simple. To what extent we in Qatar can produce our food basket, the domestic food basket. So we build the basic food basket for different population groups in Qatar, and we asked the question that what are the implication of increasing 10% of the self-sufficiency in Qatar. And what you see here in the chart is that we can manage water because energy is available, and you can provide energy for desalination and provide that irrigation, and you can have relax on the cost, and you can relax a little bit on the emission because of the increase in production. However, what we found out that in order for us to increase 10% of domestic self-sufficiency index, we need to add 153% of land, and that is not available because our land is very limited, and a lot of the land available for agriculture in terms of theoretically is a high in salinity and needs to be reformed. So those are the things that without looking at the system view, you could miss in terms of some of these questions. Moving on with another example in Morocco with the Sustainable Development Goals, we looked at the Green Morocco Plan, we looked at the Water Strategy 2030, and we looked at the Morocco Energy Strategy 2030. And the Green Morocco Plan calls for increase in olive production, increase in citrus production, and increase in vegetable production. However, a decrease in cereal production. As we all know, cereal requires a lot of land. So in order for the state of Morocco to have additional area allocated for energy and for solar, which the Morocco Energy Strategy 2030 calls for an increase by 42% in renewable energy. We have to decrease the cereal area allocated for cereal production. And the strategy for water is increase the desalination water and increase the use of treated wastewater. Now, we all know that in any national plan, all of these plans are done in a silo approach without looking at the interlinkages, without looking at the common sourcing of enablers that allow for these plans to be materialized. And in particular, you're looking at the financial cost and you're looking at the capacity, human capacity. So we did the analytical tool and we looked at all of the interlinkages and some of the trade-off analysis that we came up with, or that we found, that in the food, yes, we are compromising on food security by increasing the water, land, and energy security. And for the energy, there is a trade-off between the energy security and financial and land and water because of these trade-off. And for water and treated wastewater, because of the investment in the water and treated wastewater, that will take away from investment in the energy, and even though it will increase our security in the water sector. So you can see that achieving any national plan requires a compromise, and the nexus tools that are provided, that are developed, are only to guide these trade-off discussions that allow for cross-sectoral discussions and dialogue to happen. In Texas, we've taken the nexus to San Antonio region, and this is the the partial map of Texas. You see the green dots here are extraction wells for agriculture. The blue dots are extraction wells for municipalities, and the red dots are extraction wells for energy. And you see that all over the space there's a competition for water among these three sectors. So there has to be some solutions for the water crisis. And as I mentioned earlier, there's a 40% gap in water for the next 15 years in Texas. So some of the solutions proposed here, for the sake of time, I will not go through them, except that the point that I'd like to make here, that the solutions that exist in these three sectors, in agriculture, in the municipalities, and in the energy, are all outside the water stakeholders. So there needs to be a dialogue, community dialogue, that allows for investment outside the water sector to reduce the pressure and to provide for additional water to reduce the tension in water allocation for the various sectors. And this is again one of the success stories that I'd like to share, that the water sector needs to expand beyond the traditional stakeholders in order to provide for some of these water solutions. This is another example from Texas. The hydraulic fracturing is a major user of water, and it happens that it uses water intensely, a very short duration, and in a very localized area. And it also has some trade-off with road safety because of the implication on road safety, trucks going back and forth in rural areas. We are not here trying to impose a solution, but we're trying to create a platform for a dialogue and allow for some additional solutions that can be achieved through this dialogue. I'd like to start closing with a circular food and agriculture system. Now, if I want to give one example for an access solution for the future, is to looking at the circularity of the economy, the bioeconomy. And agriculture is one of those sectors that needs to have a closer look. The input for such a system, which at the core of the nexus is renewable water. That renewable water may not be available today, but we need to look at different treated wastewater, looking at reuse. Renewable energy is certainly in the region, in the MENA region, is on the rise, and recycling of nutrient. This is something also important outcome. And I'd like to focus here at a nutrition, human-centric food system. We need to look at this as a human-centric and look at the nutrition as the core. It's no longer acceptable for us to look at food security without looking at the nutritional security. Such a system would have a reduced CO2 emission, it would have a reduced chemical and biological pollutant, it would have a reduced food waste and loss, but also has a reduced water, energy, and carbon footprint. Those are things that we need to be discussing and developing the appropriate practices that allow us to have a circular food and agriculture system. Because of the lack of time, I won't go through the soil, but I just want to make sure that we have a pitch. Soil is an ignored resource, and we need to pay more attention to it, and soil is at the heart of the nexus when it comes to water security, food security, and carbon sequestration. Last but not least, we need to develop a more sustainable food and agriculture business model that's not based only on the production per area, which is a profit-based, but we need to look at nutritional value, we need to look at a production system that allows us to use our green water resource, which, by the way, has been also ignored in terms of the, as a principle, wastewater, brackish water, and only blue water as needed. We need to look at the production system and its the implication on water, energy, air, and the soil health. In conclusion, today's nexus, there is a projected resource gap, there is a low resilience to climate change, there is an inequity and variability in distribution and trade-off all over. Using technological, social, political, economic levers, and the role of the private, public, and civil society, we can reach a state where we have synergy between these resources and improve our equity and distribution and achieve the SDGs and improve resilience. Thank you so much.
Thank you. Thank you so much, Dr. Mukhtar, for this very extensive review and these examples of how to apply the nexus, in particular the linkage between science and policy and decision making. Now we are very pleased to have with us Professor Hani Sewilam, who is the Minister of Water Resource and Irrigation of Egypt. As you can imagine, as the main host of the Cairo Water Week, is a very, very busy person, so we are particularly honored to have him with us today. And we agreed that I would ask you a very difficult question. So you are professor of water resources and hydrology. Yourself, you are teaching water, food, energy nexus, so you are an expert, but now you also have the responsibilities as a minister. So what does the nexus mean for a decision maker like you? You can stay there or come here as you wish.
No, I can't. Assalamu alaikum. Good morning. You know, the academicians, they cannot talk while sitting. That's ask all of them. So, yeah, good morning. I'm not going to read what was planned for me to read because I can't hear the next topic and without really talking about it. But what I'm going to do, or trying at least, is to mix the nexus with my position as a minister. I don't know how yet at this moment, but it will come hopefully. First of all, I would like to thank the FAO for the long-standing cooperation. Mr. Al-Wair has been always very supportive and professional management and coordination of many activities. FAO has been in Egypt for a very long time. I even can't count the number of activities and collaboration with our ministry, but also we hope in the coming future, ESCWA also that has been also very supportive in the past and also during this phase of preparation for the many issues and many initiatives and also the next COP and beyond the COP, the UN Conference 23. So thank you very much for inviting me today. For the nexus, I can see the nexus always at different levels, starting from the nexus at the global level, and this takes us directly to achieving the SDGs. So if you take the nexus of water, energy, food, and its relation to the SDGs, it's really very difficult to imagine which one of the SDG that is not related to the nexus of water, energy, food. And definitely if you add ecosystem to the water, energy, food ecosystem, then there is no chance that you can exclude any one of the SDGs that's not related to them. That gives the importance to the SDGs and its relation to the water, energy, food nexus. And I cannot imagine achieving the SDGs without really working together at the international level to cover all the aspects and make use of the nexus at the global level. If you take it to another level, which is the regional level, and try to apply this on the situation of Egypt, then this takes me to the transboundary cooperation. And when we speak about transboundary cooperation and the nexus, I can just give a very clear example. The hydropower projects on the Upper Nile, they are having a very clear relation between water and energy, using or building dams for hydropower. So this is a very clear nexus between water and energy, but the water flowing from these dams is going for food production in other countries. So even at the regional level or transboundary level, we cannot avoid considering the nexus if we are really seeking for collaboration, and we are seeking for collaboration. How we can achieve this? Everyone can have the energy, the food, and the water necessary for that. That's brings us to another level of collaboration, and there are many scenarios that we can put, and we already put on the table how can we within the Nile Basin countries collaborate together under the Nexus umbrella, so that we can have equal rights for everyone to have access to food, water and energy. Taking it to the national level and see how is the situation in Egypt. You know all that we are receiving from the Nile 97% of our water, which is 55.5 billion cubic meter from the River Nile, which really represents most of the water. As I said, 97% of the water is depending on this amount, and the very small part of the rainfall, only 1.3 billion, and also very little amount exceeding 2 billion of the non-renewable groundwater, and I have to stress on the non-renewable groundwater. So all of this is not even 60 billion, that's all the resources we have, and if you think of 106 million inhabitants and you divide this, you will find the water share of every one of us is really somehow a little bit above the 500 cubic meter per capita per year, which means that we are far below the water poverty line, and that brings us to the energy consumption of producing water either from the water treatment or from the desalination. So if Egypt was not investing in energy sector over the last years, 4, 5, 6 years, you could have a serious problem now of establishing any desalination plant either in the north coast or on the Red Sea, because desalination itself is the cost of desalinated 1 cubic meter, almost half of the cost is energy cost. So this shows the energy contribution in the desalinated water is very high. So you need to have the energy in the country in order to be able to produce water either through desalination or water treatment. And this shows the very strong relation between energy. So people were talking why Egypt is establishing all these energy plants, why Egypt is producing so much energy that even exceeding the consumption of the country right now. Because you are looking what's coming. What's coming in the future is water production or increasing your water resources, not by any means replacing any cubic meter of the Nile water, but to cope with the increasing population of 2.5 increasing population every year. So you have almost 2 million babies are coming every year that you have to give them their water share. So you need to increase your water availability every single year. And definitely, since agriculture is consuming 80% of our water resources, so food has a very strong relation to the water resources. So you see the energy, water and food are very connected. Even if I'm a minister of water resources and irrigation and don't understand the relation with energy and food, I will have trouble. I will have a huge problem if I really don't understand this interrelationship between the three resources at the national level, and we have to coordinate with the other ministers when it comes to water for food or energy for water. In all these directions we have to coordinate and we have to work together. But now as a scientist, I can move to the last level, which is the local and technological level. What technologies we can make use of this nexus to help us in solving our problems, which mainly the water scarcity in the future. The technology that we have to focus on is using the renewable energies, mainly solar energy in the country, because we do have solar energy in Egypt, and it is a hope for us, so that the decreasing of the prices of kilowatt hour from the photovoltaic is really giving us a hope that this should be one of the main sources of energy in the future for increasing our water resources, as I said before, but from the technological